Hello Log, welcome to Data to Info. In today's video, we will look at how to create a machine learning model using an example. In today's mini project, we will look at a Titanic example. Any machine learning learner at beginning level, he or she will make use of Titanic project only. Okay, so we will look at all the essential analysis that we can do on a data set, all the EDA processes, okay, outlier detection, duplicate finding, and all those stuff. And at the end, we will predict something using our trained model. Okay, so in this case, in this mini project, we have to train a model and predict something out of it. Okay, so my plan is to give you all essential analysis steps in a one go. Okay, so let me show you all those steps that we are going to take in this mini project. Okay, so I have done all the steps before. I will just let you walk through all those steps. Let me show you. See, I have done all these steps already to save some time. I will explain you line by line. Okay, what steps we gonna take. So these are the common steps are there in any machine learning model creation. Okay. So first what we do, we gather some data. Then the second step is we prepare data. Okay. This is the biggest step in machine learning model creation. We prepare data. After preparing data, what we do? We create the model. After creating the model, we evaluate that model or test it. We can say there are A/B testing and all those stuff comes. Then we deploy it. Then we deploy our model. Usually what happens after deployment, this A/B testing comes. Okay, so these are A/B testing or some testing of the model can come before deployment and after deployment as well. Okay, for simplicity, I have put it over here. Okay, so don't be confused. So main part in this all the flow is that this data preparation. Okay, where EDA comes in. Understanding your data comes in. Okay, feature engineering comes in. Okay, so all these things we have to look at. So we will look at all these things one by one. All right, so let's go ahead and first understand what our data is. Okay, so we have to gather our data first. So first step, gather our data. How to gather our data? See, I am using Jupyter. You can use any editor you want. All right, so let's get our data into the Jupyter first. We will make use of pandas. Import pandas as PT. df is equal to, df is a data frame or a variable in which we will store our data. All right, so df is equal to pd.readcsv train.csv. Okay, now there are two kinds of data we have right now. Okay, I will provide the link. See, I will provide the GitHub link in the description down below. We have two types of data, train.csv and test.csv. Now we need both of them. Usually in the project, what happens is that you will get a separate data to train your model. After training the model, you will get a separate data to test that model, whether it is working perfectly or not, whether it has predicted the values perfectly or not. So we have train.csv to train our model, and we have test.csv to test our model. All right, you will get all the code in the practice file. All right, or slow will also you will get over here. You can access this. All right, so let's run this cell first. Okay, how we have to do some data preparation. We gathered data. We have to do some data preparation. In the data preparation, the first step is to understand your data. Now, this is a very, very essential step. This can get asked in very, very basic level interviews or beginners. All right. These questions you need to understand. You need to ask your data. How big is the data? Okay. So we have imported the train.csv data. Now let's see how big our data is. So for that, we need to apply the shape. We need to see the shape of the data. dm.shape and see. So you will see it is showing us the number of columns and number of rows into the data. Okay, so there are 891 rows and 12 columns. How much columns? 12 columns and 891 different rows. Alright. Okay. What is the second question? Second question is, how does the data look like? Okay, so we need to see our data first and understand or gain the domain knowledge. Means you should have the knowledge of your domain. So for that reason, we have the method called head and sample. Personally, I prefer sample mostly, but I want to show you both. The head will give you first five rows, first five top rows of your data. If you run it, shift enter, see, it will give me first five rows, 0, 1, 2, 3, 4, first five. Okay. By looking at this data, you will get a glance that what kind of data we have. Let's look at this first. We have passenger ID. So this is a Titanic data. You know the biggest disaster that happened back in the days. That was the Titanic which sank in the sea, right? So this is the first column is for passenger ID, right? It's a numerical column. Second one is a survived column. Survived means who survived and who did not survive. The 0 indicates the person did not survive. The 1 indicates the person survived. Alright. Then there is this P class. P class means passenger class. Okay. There are three kinds of passenger class. First class, second class, and third class. There are only three classes. Alright. Okay. Then there is a column name as well. There is a column name column as well. Okay. Then there is a gender column. Gender means 6 column. Male or female. There are only two types of genders, male or female. Categorical value. Okay. So this column contains categorical value. There are two types of values mainly, numerical and categorical, you will find in this data set. Then there is an age column. Okay. It is numerical value again. Then there is SIB, SP. What does that mean? It means sibling and spouse. Are there any number of siblings or spouse? Each passenger ID contains, yes, 1, 2, 3, likewise. Alright. Then there is this parent child, PARCH. This is a short form abbreviation for parent or child. If there are any parent child, you will get to know about it. How many number of childs are there. Then there is a ticket number as well. Okay. Ticket number as well. This is a mixed data type. There is integer as well. There is a string as well. So it's kind of object data type. We can say. Then there is a fare column as well. Fare means the price of the ticket. Okay. What is the price of the ticket? That is a fare. Then there's a cabin number as well. Cabin number column. We don't have any what we can say use of the cabin column. So we can remove that. We will see those further how to remove it. Then there is an embarked column. Okay, embarked column. What is embarked column means? It contains some categorical value. Embarked means it has some names of the places. Okay, now the full name of the places I can't write over here. So data set what they did, they given the first letter of those places. Okay, there are three different places from which the passenger pick up. This is the pickup points for passengers, right? So from this point, the passenger took this ship. Alright, the passenger took this Titanic ship. Alright. Now this is the head. I prefer this sample as well. You can use the sample alternative to the head. Okay. What it will give you? It will give you the random values, random rows from your data set. It won't give you the top 5 rows. It will give you the random rows. You can give a number of values you want in the bracket. Now I usually prefer sample, df.sample. Okay. Now the next question is, what are the data types of columns? You need to know the data types of the column. Now I told you data types of the column verbally, but you can see those using info function, df.info function. You can see the data types. Now this is called a data type. This is the columns. I will tell you one by one how to read this information. First of all, you will see 891 entries. This is rows. This is rows, your records. Okay. Total 12 columns you have. Okay. Now, what are the column names? You will see over here. All the column names. Okay. Now, this data is showing that how much non-null count are there. There are some null and there are some non-null as well. See, 891 means 0 null values. Here 714 means there are some null values in the age column. There are some null values in the cabin column as well. Okay. I can see there are some null values in embarked column as well. Okay. You can see data type. D type means data type. integer 65, float 64, integer 64, float 64. These are the integer and float values. Object is basically nothing but the string values. Object shows nothing but the string values. Alright. Then at the end, you will get how many float are there, how many integer are there, how many objects are there. Okay. And at the last line, you will get the memory usage, how much memory this data set contains. Okay. Consumes, alright. So this all information you will get using info. Now this is the little analysis you can do. Now you can check, are there any missing values or null values in your data set? For that you have to use df means your data set, df dot is null dot sum. Okay. Now these are two different methods, is null and sum. You have to combinedly use those two methods together to see if there are any null values. As soon as you run this, you will get if there are any null values in front of each particular column. So passenger ID has 0 null values. It does not have any null values. Okay. You can see age column has 177 null values. Okay. Again, cabin has a lot of 687 null values. Then there is embarked. Embarked has only 2 null values. So we have to deal with those null values as well. Okay. We have to deal with those null values as well. In our flow, we have a separate topic for handling null values. Okay. Missing C. In the feature transformation, feature engineering and feature transformation, we have how to handle or missing values. Okay. The imputation, missing value imputation, all those techniques we will see one by one. Don't worry about it. So right now we are doing this understanding our data, the basic level analysis we are doing. Okay. Very good. Now the next question we have to ask to our data set is that, how does the data looks mathematically? How does the data looks mathematically? You can use the describe method. You can use the describe method to do that. What does I mean? What does I mean by data looks mathematically? Means you will get the count of each column. Means how much count are there in each column. You will get the mean of each column. Basically, there are only numerical columns you will see. In this describe function, you will see only numerical columns, not the categorical or any string columns. See, the name column is also missing. The embarked column is also missing, right? Only numerical columns are shown over here because this is data looks mathematically. The count you will get, the mean value you will get, the standard deviation you will get, the minimum value you will get, the maximum value you will get, how much maximum value are there in the particular columns, right? The 25% of the data are around this value, the 50% of the data are around this value, right? So it's like that. For age, see, the 50% of age are around 28. So there are 50% people who are around the age 28. That is what it means. The mean value of the age is mean value. What is the mean value? It's 29.6 something, right? So this is what you will get, the mathematical understanding of your data using describe function. This is very, very easy. Then there are the next questions like, are there any duplicates in your data set? Are there any duplicates? Duplicate rows in your data set. You can check that using duplicated function, df.duplicated.sum, and you will see are there any duplicates. Luckily in our data set we don't have any duplicates, so that's why it is showing us 0. Okay, that's why it is showing us 0. There are no duplicates in our data set. Now, how is the correlation between columns? This is very, very important question. How is the correlation between columns? Now, I would like to show you df.corr is the correlation. Numeric only values I am trying to show over here in the correlation. Now, see, correlation values are between -1 to +1. It happens between -1 to +1. So, the correlation, if you know mathematics a little bit, there are two types of correlation techniques. I think most famously 2 types are there. I'm trying to show you over here are the Pearson correlation techniques. So behind the scene, this correlation function use the Pearson correlations. Okay, the range of this correlation is from -1 to 1. See, the values are between -1 to 1. Okay, so we means what it does, how to read this function, how to read this data is that we can show the analysis between two different columns. So we can show the analysis between, let's say, this age column and this survived column. Okay, let's say this age column and this survived column. It is showing me a value of minus 0.077 like this. Okay, survived column and age column. So what kind of analysis we can say? See, the negative value shows that if value of one column increases, the value of other column decreases. Okay, the positive value shows that if there are any positive value, let's say this is positive value, what it shows that value of one column increases. If value of one column increases, the value of other column also increases, right? If there are any zero value, only 0 is written. What does that mean? There is no correlation between these two columns. So this is how you can read these correlations. Okay, this is how you can read the correlation. You can also find the correlation coefficient for specific column as well. Let's say I want to find for this survived column, what is the correlation coefficient? So I have written the code over here. For survived column with every other column, the survived column relation with every other column is like this. You can see, right? This is how. Now I think we got what is the understanding of your data means, right? This is very, very basic and essential steps to perform. After that, there comes the EDA. EDA means exploratory data analysis. Alright, so let's go a little fast-paced now on. Okay, so into the exploratory data analysis, there comes the two types: univariate analysis and bivariate analysis. Uni means one, analysis of a single column means univariate analysis. Bivariate analysis means analysis of two different columns. Multivariate means analysis of a column more than one, means two or more than two different columns. Okay, that is what the multivariate analysis is. So bivariate and multivariate are the same, analysis of two or more than two different columns. Alright, so let's see one by one. First, see univariate analysis, how to do that. Okay, so the univariate analysis for categorical data, we can see there are some categorical data in our data set. Those are means survived column, passenger class, P class, and gender column. Okay, so let's draw a count plot. I want to draw a count plot to get the frequency or count of each category in survived column using Seaborn. Okay, let's do that. So I have to access first survived column, then I have to use value count function with plot function. Value count to count the frequency, okay, of values. Then I have to plot a graph. What kind of graph? The kind is bar. The kind is equal to bar. So I have to explicitly tell them what kind of plot I want to plot over here. So I haven't used Seaborn over here. So let me first show you this normal one. Okay, this normal plot. This is how the normal survived column looks like. This is a categorical column. Okay, so the analysis of categorical column shows that there are two categories in this survived column, that is 0 and 1. Okay, so using this plot, using this graph, I can tell that there are more people who did not survive, right? There are more people who did not survive. 0. There are very less people who survived. Okay, the survived count is less than did not survive. This is what it is. Now you can also show the same thing using below code as well, that is Seaborn. Import Seaborn library as SNS dot count plot. You will find count plot in that. In the count plot, you can pass the survived column. Okay, it will show you the same thing. The same graph as above, but in terms of SNS Seaborn library, the same thing. See, all right. Okay, now let's draw a plot here to get the frequency of each category in passenger class. Right now over here, I want to use the plot of kind pie chart. I want to show you in the percent format. So let's do this. using value count only. See, in the value count, there are three types of, in the P class column, there are three types of categories. First is first class, second class, and third class category. Okay. So there are more people who booked the third class category. There are very less people who booked first class and second class. Okay. So this is what analysis of the P class column as well. You can do the same thing with gender column as well, that is sex column. Okay. Dot value counts dot plot. I want to show the bar. Okay. So there are more male passengers than the female passenger. You can show that there are more male passengers than the female passenger. Okay. Now you can do the univariate analysis on numerical columns as well. Let's plot a histogram to see some numerical data. Okay. I just want to know the frequency count of data points that comes under age. Okay. Let's do a matplotlib. Let's say I want to draw a matplotlib library. Now here I am showing Seaborn, matplotlib, and all other libraries how to use it. Okay. So matplotlib.pyplot as plt, plt.hist. There are hist function to draw a plot or a chart, you can say, on age column. So on age column, you can see a histogram is there. Okay. The histogram is there. By looking at this histogram, you can analyze that there are more people lies under this range. See this range. Between the age of almost 18 to 29. 18 to 29, 20, maybe 30, 31. Okay. So most people lies within this range. By looking at this graph, you get this analysis, right? Okay. Now we can draw some box plot as well. The box plot helps us to find some outliers. Let's do a box plot on age column only. By looking at this box plot, what you can get, you will get some minimum values, some maximum values. Now these are some whiskers. This is called the two whiskers, the upper whisker, the lower whiskers. Now this is a between box. This box indicates that 50% data lies within this box. The 50% data of this column lies within this box. Okay. Now the middle line indicates the mean of the data. In this column, the mean lies within 29.6 something. See, 29.6, below 30. There is below 30. Now I have shown you the mean in upper data as well. If you remember a little, see. The mean of age is 29.6. I told you, right? Now this data, this plot is also showing us the same thing. The mean line is around 29.6 something, right? Now there are these points around the upper whiskers. It shows that these are the outliers. The points out of these whiskers are outliers. What are outliers? It is like an error or some extra points that lies away from the normal data. Okay, the normal distribution, it lies a little away. Alright, you can see the minimum, maximum, and mean values separately for each column as well. Like for each minimum value, you can see using minimum method. Then there is a maximum method to see the maximum values. There is a mean method to see the minimum values as well. Okay, there are skew method as well to see the skewness in the data. Okay, skew on age is visible. What is skewness is? The skewness is that, let me just read this. I can tell you perfectly. It indicates whether the data is skewed to left, means does the data is shift to left side, means negative skewness, to the right side means positive skewness, or it is symmetrically distributed around the mean. The mean value is, what is the mean value? The mean value is 29. Alright. And I think from 29, it is a little bit left skewed. The data is little bit left skewed. Alright. Now, after all this, you can again see the sample, how the sample looks like. Always you can see. Okay. Now, let's do the bivariate analysis. I have shown you what is the univariate analysis looks like. Now, let's do the bivariate and multivariate analysis. Little fast. Okay. So, let's see the scatter plot on two different columns. Bivariate means analysis of two different columns. So age column and fair column, let's see if there are any relation between age and fair column using scatter plot. So using scatter plot, you can see The age column lies on the x-axis, the fare on y-axis. All right, the price on y-axis. So you can see the maximum price has booked by age between 30 to 40. Between 30 to 40. See the maximum. This is looks like the outlier as well. Okay. So as the age grows, there are less and less fare. There might be any scheme that for senior citizen people, the price of the passengers are a little low. Price of the ship are a little low. There might be possibility. So this is kind of analysis you can do using scatter plot. Then you can do the multivariate analysis on top of this scatter plot as well. What you can do, you can add one more column. See, now we have added the P class and survived class as well as the gender class as well into the same scatter plot. See, and now what we can do, see, we added the hue. Hue means this box, this colorful small box is hue. Okay, then there is a style, then we pass the style as well. Then there is a size as well, we pass the size. Okay, the smaller the size is indicating that passenger belongs to first class. The bigger size indicating that passenger is belonging to third class. Okay, the color means indicating the gender that is coming into the hue. Color indicating the gender, male or female. Okay, now there is some style in the survived column, means the cross is showing that the passenger survived. Dot is showing that the passenger did not survive. All right. So this is kind of analysis you can do, the multivariate analysis on multiple columns. All right. Let's do the same thing on numerical and categorical data both together. P class is categorical, age is numerical, and this is the sex is categorical again. We can do the bar plot and do the bar plot. See, the same thing. Now there is a hue over here for the colors, and on x-axis we can see the passenger classes, first class, second class, third class, and age on the y-axis. Okay, age on the y-axis. So there are more aged people from the first class only. All right. Now let's draw a box plot on numerical and categorical data on gender and age column. See, the box plot always shows if there are any outliers. So there are outliers on male side, not the female side. Okay, there are some outliers on the male side. You can see. So the box plot always shows the data between quartiles: first quartile, second quartile, third quartile. Okay. First quartile, second quartile, and third quartile. Okay. The 50% data lies between third quartile minus first quartile. Between this box. Okay. This is what you can analyze it. There are more things to analyze it, but I will tell you in some separate video. Right now we are doing this mini project only. So that's why I am explaining it on the fast rate. You can do the hist plot as well for on numerical and categorical data. See, on the survived column, you can do this hist plot on age and survived. If the passenger survived means is equal to 1, what is the age of it? If passenger did not survive, means is equal to 0, what is the age of it? You can see the more people did not survive, that's why their columns are bigger. The KDE is equal to 2. See, it's bigger. The passengers who are survived are less. Let's do some heat map on categorical data, both categorical data, P class and survived class. Heat map. How to read the heat map? You have to see the scale on right hand side. See what the scale is saying. The scale is saying the more darker the color, the lower the value. More darker the color, the lower the value. Most lighter the color, higher the value. Now always see this scale first before reading the heat map. Because sometimes what happens that this scale is upside down as well. So value happens upside down. Okay. So more darker the color, the lower the value. The more darker the color, the lower the value. The most lighter the color, see, the most lighter the color, more the value. More lighter the color, more the value. You can say that the passenger who did not survive 0 are from first class are very, very less. The passenger who did not survive having they are from third class having a lot of value. Means more number of people are from third class who did not survive. Okay, that is what it means. How this is how you can read it, the heat map. Okay, and you can also find some calculation percentage of the survival class for embarked categories. For embarked categories, what is the percentage for survive? Okay. Now this is a false warning is there. Just ignore this warning. Okay. This is just a warning, not an error. Okay. See, from first pickup point, what is the percentage of survival? For second pickup point, what is the percentage of survival? For third pickup point, what is the percentage of survival? So this is how you can show the analysis of embarked column as well. Okay. Let me show you the shape again. This is our shape. This much column and this much column, this much rows we have. The next step is feature engineering. Let's do the feature engineering little fast. Inside feature engineering, there are 3 steps comes. That is feature transformation we have to do first. After feature transformation, there is feature construction, and then there is a dimensionality reduction. Now, this dimensionality reduction happens because of the curse of dimensionality. In the dimensionality reduction, there are feature selection and feature extraction. We may miss this dimensionality reduction, okay, because sometimes what happens, the dimensionality reduction, people do it after creation of the model, after creation of the actual model. Sometimes people do it before creation as well. Okay, so we will avoid this step. So I just wanted to know that this step has to be done for better result. Okay. Okay. All right. Now let's see the feature transformation. Inside feature transformation, there are missing value imputation. Missing value imputation. I just told you that we have some missing values in each column, in cabin column, in embark column as well. Okay. So let me show you the missing value imputation. Before missing value imputation, let me show you some missing values over here. F dot is null dot sum. See, there are some missing values in age. There are some missing values in cabin and embark. Now we need to handle this. How to handle this? The one way is to drop all the missing values. Means wherever there is a missing value in the data set, the whole row, the whole record will get deleted. The whole row or whole record will get deleted. That is what we call it, dropping the missing rows. People usually call this step as CCA, which is complete case analysis. This can be a very good interview question, that what is complete case analysis? Complete case analysis means if you will get a missing value, you can drop it, the whole row. You can drop the whole row from the dataset. Okay. For that reason, you can use df.drop now. You can use df.drop NA method. Drop NA method. Okay. But I'm not going to use it right now. Drop NA method over here. Instead of that, I will use something else. Okay. I will use something else. What is that? Impute values using univariate and multivariate. See, there are impute values with univariate imputation and multivariate imputation. Now, these are very, very important in case of interview perspectives. You can impute values using mean values, or impute means filling values. You can fill those null values using mean value of that column, or median value of that column, or mode value of that column, or any random value from the column, or end of this column, or write any missing value by your, manually. Okay. Those are the univariate and imputation. There are some multivariate imputation as well. KNN imputer or iterative imputer are very, very famous imputers for multivariate imputers. Okay. So among those, I will try to show you the mean, median or mode imputers for univariate or single column. So see, for the column of age, I would like to show you the median imputer. Now this imputer method is useful when the variable means the column has outliers or skewed distribution that might affect the mean imputation. Okay. This is where the median imputation can be used. So we know that in our each column, there are some outliers. So we can use this imputation on each column. And at the end, I am going to save this imputation or the resultant data set into the each column as well. Again, so let's run this one. After running this, um, let's see the data set. How does the data set looks like over here? Run this. See, now the age does not have any missing values. The age does not have any missing values. I have missing values on cabin and embark only. Let's deal with that. Let's deal with the embarked column. In the embarked column, I am using mode imputation. Mode imputation. What it does, the most frequent occurring values in the mode imputation. What mode imputation it does that the most frequent occurring value in that column, in that embarked column, it will get replaced with that null value. It will get replaced with that null value. I mean, the null value get replaced with the most frequently occurring value in that column. Okay. This is suitable for categorical or discrete variables. And embarked is a categorical variable. Okay. So you have to use the fill NA method. You have to use the fill NA method. Okay. First, fill NA embarked column dot mode. After using dot mode, see, dot mode, then there is a dot ILOC 0. Now what I have to do, why I have to do dot ILOC is that the mode will give me a lot of list of most occurring values. So from that list, I have to choose the top one, the first one. That's why ILOC 0. Okay. Now just run this one. And for a cabin, I can just drop this column straightforward using drop method. Drop this column using drop method because I have no use of this column. I can do no analysis on cabin data. So I can just drop it. Okay. Now I will run this is null command again and we'll try to see if there is any null values. Now there are no null values at all in our data set. Very good. After removing or dealing with null values, what is the data, the shape of the data looks like? What is the shape of our data looks like? df dot shape. df dot shape. Let's see. The data is looks like one column has reduced. There were 12 columns. Now there are only 11 columns. Now the next step is handling categorical data. Now the next step is in feature transformation. The first was handling missing value imputation, right? Now there are be handling categorical features. Features means columns. Handling categorical columns. Okay. Now in the categorical columns, usually what happens, we can't go with the categorical columns and create models out of it. Okay. So what we do is that we convert those categorical columns into numerical columns using some encoding techniques. Some common encoding techniques are listed out over here. Okay. There are more than these three encoding techniques as well, but most common are these: one-hot encoding, label encoding, okay, ordinal encoding. These are some encoding techniques over there. Okay. One-hot encoding you can use for nominal data. For ordinal input features, you can use ordinal encoding. For label features, for categorical features, you can use label encoding. Okay. So over here, for our Titanic data set, for numerical and categorical data, you can use those encoding techniques. See, you can uncomment this much code and try label encoding on embarked data. Okay. Embarked data, you can try label encoding. You have to make use of .fit transform method. And you have to first import the label encoder class from scikit-learn, sklearn.preprocessing import label encoder. Then from this label encoder class, you have to create an object. This is a label underscore encoder object. Okay. Using this object and fit underscore transform method applied on embarked column, you can encode it into a numerical feature. This categorical feature will be converted to a numerical feature. But if you don't want to do this, there is another way as well. This is the another way of converting categorical features into a numerical value. Okay. So let's say there are two features, this gender feature and sex feature, and this is embarked feature as well. Now these two columns, I want to convert these categorical columns into numerical. So I'm assigning numerical values 0, 1, 2, 3, likewise. Okay. For female 0, for male 1, likewise. And for embarked column as well. Okay. And let's run this code. Let's run this code and see how our data looks like. Now see, embarked has converted into a numerical. Okay. The gender has always also converted into a numerical column. Very good. Now let's do some outlier detection. What is outlier? I just told you it's like an error or some value that is lies away from the most of the population, most of the distributed data. It lies away, far away. That is what called the outlier. How to detect the outlier and how to remove the outlier. Those are techniques listed out over here. Okay. See, there are Z-score technique, IQR, interquartile range that we call it. Okay. Then there is percentile approach technique. Okay. Where we do some trimming and miniaturization as well. Then there is a MAD technique. We call it median absolute deviation technique. There are much more techniques as well, but these are some common techniques. I think you should be familiar with Z-score, IQR, and percentile approach. These three techniques you should be familiar with. In our example, we are going to make use of this percentile approach. Okay, we are going to make use of this percentile approach on H column, because we know that there are some outliers on H column. I showed you using graph as well, using box plot as well. So let's do some describe on H column. You can see the mean of the H column is around 29.36. Okay, 50% data lies within the age 28. Okay. There are some maximum as well. Maximum is 80. So you can see that 80 shows some outliers. 80 shows some outliers. So we have to remove those kind of outlier as well. Now let's plot some histogram on age. Histoplot on age and see. Over here, right hand side, there are some outliers. I think 80 side. Okay. Let me show you using box plot. See, on box plot, the horizontal box plot this time I have I'm showing you the right hand side and left hand side. There are some outliers. Okay, the left whiskers, away from the left whiskers, there are some outliers, and there are some more outliers on right whiskers as well. Okay, we have to eliminate those. So I am using percentile approach. We can do dot quantile. Okay, so we have to set the upper limit and lower limit. And we have to consider data between these two limits only, not out of these two limits. Whatever data lies out of these two limits, like the more than this upper limit and lower than this lower limit, will be considered as outlier. So this is the threshold value I am putting inside brackets. So 0.05 means whatever value is lower than 0.05% will be considered as outliers. Whatever value is more than 0.95% will considered as outlier. So make sure that the adding up these two values, you should get 100%. It's not like you should not get 100%. Okay, adding these two values will get 100%. So 0.95 plus 0.05 will be 100%, right? Okay, so just run this code real quick to get this upper limit and lower limit. So means the age is more than 54 will be considered as outliers. Age lower than 6 will be considered as outliers. Okay, so let me show you how that data looks like. The data greater than and lower than this upper and lower limit. How those data looks like. This is how this data looks like. Okay, so this is what the outliers data looks like. Now I just want to remove the outlier. So what I'm doing, I am converting this signs to the other way around. Okay, and putting and in between those. Okay, and storing the same data into a DF data frame. Storing the same data into DF data frame and checking the shape of it. Now, after checking the shape of it, now you can see the more rows have deleted. Right? Let's see the histoplot for this distribution. Now this looks better. X-axis, you can see the distribution has shortened up. The box plot, if I can show you, there are a lot of outliers has deleted. There are some outliers are there still, but it's okay, because it should not be like the case that you remove all the outliers and lot of data from your data set gets deleted. So in that case, our model will not work properly. So if there are a lot of rows that has outliers, so it's okay to keep some of the outliers and remove the extreme outliers. This is what you have to do. Then there is a feature scaling. Okay. What is feature scaling? Feature scaling means basically um, moving your whole distribution towards the mean. There are two types of feature scaling: standardization and normalization. We are going to see the standardization only. Okay. Let's do the standardization. What does mean by standardization is that I will show you how to do it, but behind the scene, how it is working. For that, you have to understand how standardization function works or class works. So, in the simple term, if I tell you what we are doing, feature scaling means using standardization is that we are making mean is equal to 0 and standard deviation is equal to 1. So, we have to make the data according to mean is equal to 0 and standard deviation is equal to 1. This mean centering should be towards the 0. So I have to do feature scaling, let's say, on these two values, fair and age. So what I'm doing that I'm taking these two data separately into the separate data set, that is new df. Okay, first, and then checking the shape of this new df. Let's say this is two column only, okay? And applying the standard scalar class from scikit-learn dot preprocessing and creating the object of it as a scalar. Using this scalar object, I am doing the dot fit for this new data frame. Okay, and then transforming this new data frame and putting it into again a new data frame called df1. Okay, let me run this one. Okay. After running this, what I'm doing, the df1 will give me a array. df1 will give me the result in array, not in data frame. Let me show you. df1 will give me data into this array format. Okay, but I want the data into a data frame format. That's why I have to convert it into a data frame using this data frame function. Okay, put it into a new variable df underscore scale. Let me show you this df underscore scale. How does this df underscore scale looks like? This is how this df underscore scale for these two columns looks like. Now I can just concatenate, means merge these two columns into the normal data frame, this original data frame. Okay, using concat function. Okay, now see, I have merged these two scaled values of columns into this data frame. Now there are some redundant columns now. This is our scaled columns, and now this is our age twice. The fair columns also comes twice. So what I can do, these old columns I can remove. Age, fair, I can remove. Okay. Are there any null right now? There are some null values. See, this is the problem with the scaling the data set. There comes a lot of null values, so you have to take care of it again. So what I can do, I can use this drop na function to get rid of these null values. df dot drop na. If I run this one again and check, now there are no null values. Okay, there are no null values. Let's do some feature construction. What is feature construction is that, see, feature construction or feature splitting is the thing is that we can add new columns, we can add new feature or variable into a data set. Okay, or we can split a single column into two different columns as well. That is what called feature splitting. So let me show you these both things. First, we will do feature construction, means adding a new column. There are one column I want to show you. Wait. See, this data frame, there is one column called sibling spouse, and there is another column called parent child. Now what I can do, I can combine these two columns and create only one column out of it, and we call that column as family size. Anyway, this is the family size. These two columns combinedly makes the family size only. So what I will do, I will write this code to make a single column called family size. Okay, I will run this code. Okay, now ignore the warning. These are the warning, not the error. Okay, family size. This is how it looks like. Family size. Okay. Now what I will do, what I will do, I'm writing this function to assign the values, uh, out of this family size. So what I can do, if the family size is equal to 1, I can return the value as 0. This is very, very small family size. If the family size is greater than 1 and less than 4, I can conclude that this is a very, very small family again. So I can return 1, but it is a little bit more than 0. Okay. If the family size is greater than 4, then that family is very, very large family. I can return 2 at this place. So 0, 1 and 2. And converting these family size values into 0, 1 and 2 and creating a new column called family type. So I'm using this apply function. I have already written an article on how to use the apply function and all. Okay. So I'm using this apply function and passing this my function column to it, using this family size and creating this family type column. Okay. After running this, just check. Okay, sorry. What happened? I haven't run this one. Okay, sorry. Okay, now it's run. Now, if you see the data, there are new column called family type. If you got the column for family type, you can remove these 3 columns: sibling, spouse, parent, child, and family size. You can remove this, drop this column. Now we don't need this column because we have created an ultimate column called family type. Okay. Ignore the warning again. Okay. See, those columns has removed and only family type is there. Okay. Now do the feature splitting, means how to split a single column. Now there is a column called name. I can split this column into multiple columns. Let's say there are some salutations in front of each and every name of the passenger. We call it salutation, right? The prefixes, Mr., Mrs., right? These are the titles. We can split it. Let me show you. This is the name. Okay. These are salutations. Mr., Mrs., Master, Miss, right? What I can do, I can split it using split method. Just dot string dot split and split it on the delimiter of dot. Split it on the delimiter of dot and comma. Dot and comma. Let me split it and convert it into a title. Split it and convert it into a title. So I can show 2 different things, title and name. The salutation is different and the name are different. Okay. Now I can show some analysis out of it. You can run some analysis on this splitted column separately or individually using group by command. Okay. So by using this analysis, you can conclude that I know the data that there are some more records on Mr., Mrs. and Major values. By looking at this data, I can see these 3 salutations has more survival rate. So you can do this kind of analysis as well if required. But it's unnecessary right now for me to create this model. So what I will do, I will just drop these 2 columns again. Name column, and also I don't need the ticket number column as well. So I will drop that column as well. So now this function and this line of code is also very, very important. What this does is that if there are any multiple duplicate columns are there, it will remove those duplicate columns. Okay. So I'm keeping the last column which are duplicated, but I'm keeping, I'm dropping the first occurrence of the duplicated columns. First occurrence. This is what I'm doing. Now see, there are only 1 H column, 1 fair column. Okay. There is no duplicate right there. Very good. Let's do the dimensionality reduction. As I told you, I'm not going to show you the dimensionality reduction. because people usually do this after creating the model. Alright, so you can perform this dimensionality reduction. Okay, this is very important step again. Right now I'm skipping it. Let's go to creating the model. Let's go to creating a model. Okay, I am using the algorithm logistic regression. Okay, I'm using the algorithm logistic regression for creating the model. So let me first tell you about the logistic regression. If you can see this diagram, the logistic regression algorithm, this is a logistic regression algorithm. This comes under supervised learning. Inside supervised learning, there are classification and regression problem. This logistic regression comes under classification problem. Classification problem is categorical data in the output column. We have survived as an output column. We have survived as an output column. So let me tell you, how did we find out that we have to use the logistic regression, or which type of problem it is. Then in machine learning, the problem is supervised or unsupervised. How do we get to know that? Okay, the problem is supervised when there is some input columns and there is one output column. There is some input column and output column, then the problem is supervised. Okay, then how do we know that problem is classification problem or regression problem? If the output column is a categorical column, then it's a classification problem. If the output column is a numerical column, then it's a regression problem. Right? In our case, the output column is a categorical column. That's why we have to go for categorical algorithms. In the categorical algorithm, we can choose any one of the algorithms and see the model and create the model. So we are going with the logistic regression. We are going with the logistic regression. That is what we are doing. Let me show you the data set first. This is our data set that we have prepared so far. Okay. We need to drop this title column as well. So let's drop this title column. We don't need that. Okay. After dropping the title column, the shape is like this. Only 8 columns we have. Okay. We have to do train test split function. Why do we need to do this train test split function? Is that we find this in sklearn, scikit-learn only, model only. Why do we need to do this? That it breaks our data. It breaks our data into 2 different parts. One is for training, other one is for testing. So X is for input, Y is for output. Train is for training and test is for testing. Okay. So X train, Y train, X test, Y test. Okay, like this. There are some 4 to 5 parameters inside it. I have given. What are the parameters? That first parameter is the column that we have to provide, or the data that we have to provide. So I have provided all the data except this survived column. That's why I have dropped this column. So the rest of all the data except this survived column will get provided. All right. And then the second parameter is test size. What is the test size is? Test size means the 0.2 means 20% of the data I am keeping it for test size, and remaining 80% is for training. Okay. Random state, I can provide random state anything. Let's say I provide it for 0. Okay. Stratify is survived column only. DF survived. Let's run this code. I haven't run this code. I think train test split. After running this train test split, let's use logistic regression model from sklearn, scikit-learn only. Okay. First I have to call the logistic regression class, then create the object out of it. Then using that object, fit the model and pass X train and Y train. Okay, because it is a training data. X is input, Y is output. Okay, but both are training data. Fit on training data. Then using accuracy score, try to predict it on test data. To show the accuracy that how good our model is performing. So using the object.predict function, and you will get a value of prediction. Use that value of prediction and your actual value of test to see the accuracy. So accuracy score will compare this value y test and y predict and show you the value accuracy value. This is how the accuracy value looks like. Now ignore this warning. This is just a warning. Our model is 83.5% accurate. 0.835 shows. If you convert it into a percentile, it will be 83%. So our model is 83% accurate. Now my intention here is not to show a perfect created model. My intention here is to show all the basic steps that can come inside creating a model. Okay. Now this is how our data frame looks like. You can create a confusion matrix as well and show it using a heat map to show what is the our created models are saying. So how you can read the heat map, I already told you. Just read the scale on the right hand side. The darker the color, the lower the value. The lighter the color, the more the value. Okay. This is how our confusion matrix looks like. How to read it? See, the passenger who have survived. Now there are 4 things into the confusion matrix basically. True positive, true negative, false positive and false negative. We have to go very, very deep into that to understand it. I am not going to waste time to show you and explain you all those stuff. Let me go for processing test data. Till now what we did, we processed the training data only. Okay, now we have to process this test data, this test.csv, alright, and do the same things again on test data as well. And then at the last, we have to compare the test data and the train data. See, just import the test.csv. This is how our test data looks like. In our test data, if you take a closer look, there is no survived column. Why? Because survived column is our output column. The output column is not into the test data, testing data. Okay. What is the prediction? In the prediction, we have to repeat all the steps that we did for training data. Now I'm going to run all these steps. Filling missing values, dropping unnecessary values, feature selection or the scaling. Sorry. Then there is some encoding. The encoding is happening. Okay. Then there is this thing is, I think, for outlier detection. Okay. Then there is a standard scalar encoding. Okay. This is false. Then drop the unexpected value. Okay. There is one we did for family size, family type as well. Okay. Drop it and drop the duplicated columns as well. Okay. Now, after doing all these things, your test data looks like this. After doing all these things, your test data look like this. Okay. And your original train data is under DF. This is our train data under DF. And under test, you have our testing data. Okay. So testing data and DF data should have some common columns. Should have all the columns that are in testing data should be available into the training data. Should be available into the training data. Okay. Now I can do the predict on test data. I can do the predict on test data and see what are my predictions. Is my predictions correct or not? Now these are my predictions. Okay. Now let's put these predictions into a file called submission.csv. Okay. Let's put these predictions into the file and show only passenger ID and survival predictions. And read those CSV file. And you can show some count plots as well and show the predictions. According to your predictions, what you conclude that there are very, very less number of people who survived and more number of people who died. So these are the number of people who died. Right? So this is what the prediction shows that. Means when you pass this testing data to our model, when you pass the testing data to our model and you do this prediction, when you do this prediction, our prediction shows that whatever the input you give me, among those, this much people will be survived and this much people will not be survived. Okay. So how this submission file looks like, let me show you. Let me show you the submission file that we downloaded. Okay. This is a submission file that we downloaded or created. there is a passenger ID and survived column, right? For each passenger or survived column from test data set, right? This is the passenger ID from test data set. So from this test data set, we conclude that this much people will survive and this much people will not survive. Means 0 means not survived, 1 means survived. Okay, this is what we analyzed, or this is what we predicted beforehand using our created machine learning model using logistic regression. All right, so that's it then. These are the all we can say steps that we use to create a machine learning model for beginners. If you are beginners, let me know how you like all these steps to see at one place, from data gathering to data preparation, EDA process, feature engineering, right? The modeling creation, okay? Model evaluation. Model evaluation means nothing but to predict the model, okay? Then model testing, you can do it after development as well, or before development as well, whatever you can do. A/B testing is a whole lot of new thing, so please don't get confusing to this. The model deployment, we are not going to deploy it anyway because we don't have any server to deploy it. This is our only mini project, not a full-fledged project, okay? So this is what we can see into the mini project of Titanic prediction, survival prediction. All right. If you like this mini project, hit that like button. Do subscribe to the channel. Also join the WhatsApp group. You will find a link into the description down below. Let me know how you are doing. Till then, as always, peace out.
Goo goo gaga.
Smelly cat, what are they feeding you? Smelly cat, it's not your fault. Smelly,